Right, so next I want to tell you about section 12.6, which deals with surface area. This is very cool. We're going to actually be able to compute the area of a surface in 3 dimensions. And we'll begin by thinking about surfaces which are given parametrically. So here's the parametric form of the equation of a surface. You have some x component, some y component, some z component, and each of these depends on 2 parameters, u and v. So in the example, we've seen this kind of thing before. We looked at how we would calculate the tangent plane to a surface given parametrically. We've done that before. So if you've forgotten about that, you might like to go back and take a look at how we did that. And we'll see later an example of where these parameters u and v might come from. What does this actually mean geometrically? Well, u and v are some variables which describe some 2-dimensional surface. Okay, so let's say D is a domain in 2 dimensions, and u and v are our coordinates. R, the equation for the surface, is a function that maps this 2-dimensional region into a 3-dimensional surface. Okay, that's what R does. So what does it do on these horizontal lines? The horizontal lines will get mapped to curves on the surface. So let's just look at some example. Let's suppose we have this one. It'll get mapped to some curve, say this one, on the surface. Okay, and similarly, if we have some vertical line, let's say this one, it's going to get mapped to some vertical line, some curve, sorry, not a vertical line anymore, some curve that runs along the surface. Okay. So this surface is just some sheet in 3 dimensions, right? That's what the surface that we end up with is looking like. One way to think about it is to take this little piece of the plane over here and deform it, stretch it, bend it, and then you end up with some surface in 3 dimensions, and that's what this is. So that's what R does. It takes this piece of the plane and gives you a surface. Now, if we want to find the area of the surface, what we will do is to chop up the surface into little blocks. Okay, that's what we're going to do. Chop up the area into little blocks like this. And so each of these is some little curved surface. And now we can approximate the area of any such block. Look, like this green block, we will call this a patch. We can approximate the area of this patch on the surface. So how can we do that? Well, anytime we can, if we're dealing with some curved surface or something like this, we can flatten it out. And you know how to do that. That's the tangent plane, right? So this surface is very well approximated close to, let's say we take the tangent point at one corner of this block over here. So the tangent plane that just touches the surface at the point very, very well approximates this bent little piece of surface. So instead of calculating this area of this bent surface, which might be very complicated, we can approximate it by the area of a little parallelogram on the tangent plane. Okay, so the area of a path on the surface is approximately the area of a parallelogram on the tangent plane. Okay, so in the next video I will tell you how to actually work this out.